So we're going to use this cute little, not so little formula up here called the quadratic formula to help us figure out solutions of a quadratic that maybe we couldn't factor, or maybe we don't feel like completing the square or doing something like that. Nice thing with the quadratic formula is it works for everything. If it's a quadratic, you can solve it with this. And the nice thing, if sometimes you have tricky parts, remembering how to remember what a formula is, what I always tell people is it's going to be two formulas that you've actually dealt with or are going to be dealing with put together. For instance, negative b over 2a should look familiar. It's how we find the x value of our vertex. So that's part of what we've been doing already. The rest of it, this b squared minus 4ac, is going to be something we talk about in detail here in a moment, which is called the discriminant, which is how we figure out how many solutions there are to the quadratic we're working with. So it kind of helps you to remember what that's going to be, because you do need to have that drilled in here when we get into the tests and quizzes and things like that. One other reminder with the quadratic: before you start plugging numbers in for a, b, and c, it always has to be in a format where it's ax squared plus bx plus c. In other words, you need to see that equals 0 there. For the first two, that's going to be cool. For the third one, be careful. So when we start doing these, it's going to be as simple as plugging in those coefficients to figure out a, b, and c. And then it's basically detail work from here. And when I say detail work, little things like it's negative b, making sure that you change that value to -1. Making sure the plus minus doesn't disappear. Not so important when it's a positive number, but when it's a negative, putting the parentheses around it. Okay, so minus 4ac all over 2a. So you're like, okay, not much else could cause me trouble here. Well, yeah, actually there are some things that could cause you trouble here, especially if you go to the calculator. I'm more of a fan of trying to do as much of this in my head as I can, because I trust my head more than punching the button into the calculator. Let me show you a prime example. Let's say I decide, okay, I want to do this radical part. I'm just going to let the calculator do the work for me. So I start typing along, and I'm like, okay, minus 4 times 2. I'll type it just like I see it here, and I hit enter. Now, if I didn't know any better, I would actually think that was the right answer. You're like, it's not? I'm like, no. Because let's say I did this in my head, and then I'll show you where the dilemma lies. Okay, 1 squared is 1. 4 times 2 is 8, times -5 is -40. So it's 1 minus -40. You're like, see, it's 41. Right, but it's the square root of 41. What went wrong? What'd I do? The problem is, if you're doing it on the calculator, once I close that parenthesis here, the calculator did the square root of 1, squared it, and then just minused all this stuff. Well, that's not what I want to do. So if you're not going to do it in your brain, here's what I would suggest. I would suggest doing all that stuff underneath, but don't plug it into the radical right away. I don't care if you want to do a little bit of double checking, or, your brain's tired and you want to let somebody else do something for you. Okay, I get my 41, but then I still need to remember what's the square root of that number. And if my radical doesn't break down, just leave it alone. I'm done. Because we just want exact answers, but we do want them simplified as much as we can. Now, it doesn't mean go to a decimal. It just means if this happened to be like the square root of 40, I'd break down the radical, and I'd simplify it as far as I can. So some of them will allow me to do that. Some of them, not quite so much. So let's see here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, let's do a little mental math here. 4 times 4 is 16, -48. 1 minus -48 is like 1 plus 48, which is 49. Here's a prime example. Square root of 49, perfect square. That's awesome. So that's going to be -1 plus or minus 7 over 8. Now, If you can simplify it, and you certainly can with this, you need to. If I can get the exact answers out, for instance here I'd have -1 plus 7 over 8 and -1 minus 7 over 8. Notice I'm putting the numerators in parentheses. If you're going to the calculator, you need to do that. Because if you just type -1 plus 7 over 8, you're going to get funky answers. So let's see here. -1 plus 7 is 6. 6 over 8, but that reduces to 3/4. And I suppose I can deal with a decimal if you want me to. -1 minus 7 is -8. Negative divided by positive, -1. Okay, so if you can completely simplify, you need to. Now let's find some more twists here. What else can cause trouble? That 35 can cause trouble. Remember, everything on the x squared side. Normally I suggest taking the 5 seconds to rewrite the equation in standard form, because then I can be sure I get the correct c value, which isn't positive 35, it would be negative, and that one sign messes you all up if you forget it. So let's see if any other interesting twists come up here. -b squared minus 4a bless you c all over 2a. All right, am I going to trust myself on this one? Nah. It's been one of those days. So let's get a little assistance here. 8 squared minus 4 times 3 times -35. Now I do know for sure that you are a perfect square, sir. Yes, you are. So similar to what we had happen in number 2, if it breaks down cleanly like this, you do need to split and conquer. -8 plus 22 over 6. -8 minus 22 over 6. Let's see. 14 over 6 simplified would be 7/3. Or if you went to 2.33333, I guess that's okay. -30 over 6 is -5. But again, the fractional technically would be more exact as far as trying to get that situated. All right, let's see what else we got down here. We'll get a couple more of these in. I'm waiting for my other secret plan to come in. All right, everything's in the right spot this time. That was nice of me. We're going to do this one in 6. All right. This is just once you get on a roll, b squared minus 4ac all over 2a. So we're like, okay, let's see here. 16 minus -56 would be 16 plus 56, which is 72. Here's a first. This is the one I've been waiting for. Now this time you look at it, 72 is not a perfect square, but 72 can break down. So what does 72 break down into? 36 and 2. Now if you would have done 9 and 8, that's okay, but you're going to have to break it down twice. So here I have -4 plus or minus, square root of 36 is 6, square root of 2 over 2. But there's even more. Because now that I've broken it down, I can look at all 3 of these terms. And if the numbers, not including the one underneath the square root, but these 3, have something that's divisible into all of them, that's another way that I can reduce this. So since these are all divisible by 2, and that's just going to be 1, so I really could just leave it this way. If I put it over 1, it wouldn't be wrong. So if you can break down the radical, even if it's not perfect, do so. And if you can see some other way to keep reducing, keep reducing. So you're like, okay, might come out perfect, might come out where I can't do anything, might come out where I have to break apart. Is there anything else? Yes. One more. One more situation we can run into. And again, make sure you don't get sucked in. This C value is not negative 25. That guy needs to come over here. So this equals 0. All right, one more situation. Now, again, details. It's negative b. It's the opposite of b. So don't put a negative 2 there at the start. That's positive now. B squared minus 4ac all over 2a. All right. Ooh, this looks like fun. All right. We're going to play it safe. So we've got negative 2, don't forget your parentheses, squared, 4 times 7 times 25. Ooh, a new sort of fun. 696. Okay. So let's see here. We have a couple of issues. First issue, square root of negative 696. Uh-oh. Now what? Oh, hidden behind the game. Take an eye out. 2 plus or minus I square root of 696 over 14. So now that I got rid of that ugly negative, because negativity does so many bad things, doesn't go in nice. Well, let's see. I wonder if there's something that goes in this. I wonder if this is like number 4, though. Let's see here. Let's play. Oh, what might go in? Yeah, I don't think so. Okay, I was right. No. I know 25 won't work. I'm pretty sure 9 doesn't work. I hope I'm not just wasting my time here. Oh, winner. Okay. It's a small one, but it works. So 174 and 4. So sometimes just the littlest one can be there. So you're like, holy cow, Harty. Hopefully you write smaller than I do. 2 plus or minus. Okay. Square root of 4 is 2, so that comes out with my I. Square root of 174 over 14. Ugh. Anything else I can do to this thing? Yeah, I can get a 2 out of each of these. So 1 plus or minus I, and you could put 1i if you wanted to. 174 over 7. Eee. So lots of things can happen here, basically is the lesson. It can be a radical. It doesn't break down. It can break down clean. It can have an I. It can break down partially. We don't know. That's why we got to work through it and do it. And that's why this is a nice tool, because it works for everything. So now we can actually take it back a little bit and make life a little easier on us for a minute. We're only going to use part of the quadratic formula for the next part here. So the discriminant is b squared minus 4ac. Basically, wonder just what's underneath the radical. If my answer is positive, if it's greater than 0, I have 2 real solutions. I'd find 2 intercepts if I were to graph it. If it's 0, I have 1. It would basically just hit the x-axis one time. And if it's negative, if it's less than 0, there's 0 real solutions. I'd have no x-intercepts. All my answers would be imaginary. So we're not looking for solutions here. We're just looking for the number. So I'm still going to do, so b squared, use my parentheses, minus 4ac. But I don't have to do all the other stuff. So let's see, 36 minus 12 is 24, would give me 2 real solutions. So if I were to put this in the graphing calculator and hit graph, there would be 2 x-intercepts that I could find, or that I would see. So that's another way to kind of do this if you forget something sometime. So on any of these, again, on your b squared, always remember the parentheses. Minus 4ac, let's see, 100, 136 is negative 36. Now, just to prove a point, I keep talking about if you use the calculator. Well, I need to quit talking about if we have one available. So if I wanted to double check sometime, I could just take whatever the expression is, type it in, look at it. I can only see a little piece of it up here, but I do notice that's never going to cross the x-axis. It's opening upward and it's up here. That shows me the 0 reals. I still have imaginary solutions, but that's kind of a visual way of letting me see how that would work. Same thing here. b squared minus 4ac. 64 minus 64 is 0, which would be 1 real. And again, you sort of can visualize what that would look like. If I type this in, you also notice, hopefully, it's a perfect square trinomial, which is another giveaway for hitting it one spot. Just this one spot right here at negative 4 would be the only solution that I'd have. So if I were to factor this, if you think of it that way, you'd get x plus 4 squared. So I'd only get one answer. That's where that's coming from. So that's where the factoring comes together with the graphing, and it all kind of comes together in a big piece. But that's all I use the discriminant for. How many answers can I get? So find the discriminant, determine the number of solutions, and get the answer. Holy cow. That's a lot of stuff to keep track of. All right. Find the discriminant. b squared minus 4ac. 36 minus 40 is negative 4. 0 reals. So what's that telling me? It tells me I is going to be somewhere in my answer. So the discriminant gives me some hints. So now, when I go to actually find the answer, let's see, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's see what we got here. Negative 6 plus or minus 36 minus 40 is negative 4. Yep, I see the I coming. But here's the cool thing this time. When I pull the I out, I have a perfect square. So here, negative 6 plus or minus, bless you, 2i, because it'd be I square root of 4. Square root of 4 is 2. All over 2. Oh, bless you. Holy cow. But again, as it seems to be happening a lot, I have a 2 I could take out of all of those. So negative 3 plus or minus I, and again, I don't have to put the over 1. There's my 2 solutions, and they're both imaginary. These 2 things will always coincide with how these are going to work. One more just to be sure. Let's play with number 11. Let's see here. B squared. Oh, I'm already into the quadratic. B squared minus 4ac. So 25, negative 20 minus negative 20b plus 20 is 45. Positive number is getting me 2 reals. So this time there should be no i's. I still can get radicals, but no i's this time. Let's see. So again, detail, Negative b, the opposite of negative 5 is 5, plus or minus the square root of b squared minus 4ac all over 2a. All right, let's see what we get this time. Negative 5 squared is 25. Negative 20. So 25 minus negative 20 would be 45 over 2. And again, if you can break down the radical, you should. It's just a good habit to get into. So 9 and 5. Square root of 9 is 3. Square root of 5 over 2. Now this time, I don't have something that goes into all of them. And even if you got a situation sometime, like let's say this was 4, even though 2 goes into 4, it's got to go into all of them to be able to reduce. It's all for one or none for all. So that's as far as I'm getting, and there's my 2 real solutions. Okay? So, how are we going to bring all of this into what we've been doing? Well, down here in basically our last part, we've talked about the axis of symmetry and how that goes along with the vertex. Well, it's also going to help us a bit when we're doing max and min. So we're going to find the equation for the axis of symmetry and the coordinates of the vertex for each parabola. Okay, we've done that before. Then find the x-intercepts using factoring the quadratic formula. Okay, we got lots of pieces going here. So in this case, to find my vertex, I can do a couple of things. One of them, again, remember, is to use my x equals negative b over 2a. That's finding the x value of my vertex. So, negative b would be the opposite of negative 2, which would be 2. Over 2a. So x equals 1 is my axis of symmetry. It's a vertical line going through the center of my parabola. So my vertex then is just going to be at 1, and I can either substitute in, or if I had it in the calculator, I could look at the table. So 1 minus 2 would be negative 1 minus 15 would be negative 16, because I already got the x value from finding the axis of symmetry. And then it says, then find the x-intercepts using factoring of the quadratic formula. Let's see if we can factor this. Factoring's always a better option. It's just faster. So let's see. 2 numbers that multiply to negative 15 but add to negative 2. Negative 5 and 3. And then I just set those. It's not these values, because remember, you're setting them equal to 0. So basically, it's just going to be opposites. And that will get me my 2 x-intercepts, and I'm set. So if I were graphing, this would be great, because I have 2 points here. I have a third point with my vertex, and that's all I need to be able to make my parabola. So whenever we're doing these, so let's see. Let's do another one here. I'm going to do a couple of different ones here again. I think we're going to do 14 and 16 are the 2 that are going to get us the most bang for our buck. So let's see. Axis. X is going to equal negative b over 2a. Ew. Negative 1 over negative 2 is a half. All right. Not the most fun, but we can deal with this. Now again, if you want to on this, and typically we're going to be a little happier, and I'll get this out of your way, we're going to be a little happier here if we go all fractional or if we go all decimal. I really don't care which, but if you're going to do these, remember that negative is outside of your x squared this time. So when I do my negative, then I'm going to put my 1/2 or my 0.5 in the parentheses. The negative does not go in your parentheses here, because if you do that, well, it's not going to work out. And I don't care if you do 0.5, 6.25, but if you're going to be fractional like I am, I'm going to stick with fractions. Or 6 1/4 if some of you are mixed number fans. Now, factoring here. Normally, negative values in front of x squared make this a little bit complicated. So here's what I do. If I were to move all of these terms to the other side of the equation and bring things back around, I can play with this a little bit. So you've got to think a little bit about what you want to do. If some of you don't want to deal with the negative that's in front here, what I could do is I could go to the quadratic formula to try and simplify life up a little bit. I could just go ahead and go, okay, let's see. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Because I think we're going to find out something here in a minute, but we'll just discover that. So negative 1 plus or minus 1 minus negative 24. 1 plus 24 is 25. So let's see here. Ooh, perfect square. And the perfect square lets me actually get to the values here. So let's see. Negative 1 plus 5 over 2. Negative 1 minus 5 over 2. 4 over 2 is 2. Negative 6 over 2 is negative 3. So my x-intercepts would be at 2, 0 and negative 3, 0. Now again, could I have factored with that? Yeah, it just makes it trickier with that negative. But if you're comfortable, I don't care. Here, think about for a moment what you could do. You might not even have to completely factor this to find your intercepts. You look, now this one's a little nastier. I was going to skip it, but now I'm seeing this kind of nasty. So maybe we should do this. Because here, oh yes, yes ma'am.
How are the x-intercepts in 14 negative 3 and 2? Wouldn't it be 3 and 8?
All right, let's check this out. Make sure something didn't go haywire. Negative b plus or minus b over 2a. I'm just trying to think about it factoring through wise, but I should check what we've got here too. So let's see. So we've got b squared minus 4ac. Oh, she's got something.
If you look in your denominator, you didn't bring the negative 2 over.
Oh, nicely done with both of you. Hang on a minute. Incoming. I wonder where he looks. Incoming. Incoming. That's the detail stuff that I always get on everybody else about, and then I miss my negative. What the heck? Gotta be careful with this stuff. So now let's see. Hopefully I don't do that again. Well, I still got candy left. It's okay. People online are like, what is he doing? He's talking about incoming. I'm throwing things. Okay. So here, let's see. Hopefully we get through this one a little cleaner. So my Axis Symmetry, we've got negative b over 2a. 3 halves. Yuck. Now again, if you want to go to the decimal form, you can feel free. Now that I'm slightly gun shy at this point on this one, I am going to make sure I put this in carefully. Again, my negative is going to be outside my parentheses because that's the way it's written in my problem. Anytime you're going to use a fraction, make sure we use the parentheses too. And again, if you went decimal for your first part, 1.5, using the decimals, fine. Just try not to mix and match. 9/4. Now here, it's a little bit different because now I look at those and I go, hey, wait a minute. They have a common factor. Now, I have a decision here to make. I can either say I'm just going to pull an x out at the start and then have negative x minus 3, because x times negative x is negative x squared, positive times negative. Holy cow, Harty. Whew. Positive times positive is positive. I was thinking if I had pulled the negative out. I can do it this way, or if you pulled the negative out, those signs would just switch. Either way, I'm going to set each of those equal to 0. And I'd have intercepts at 0, 0, and 3, 0. That's better. And again, sometimes you may get fortunate and everything will just factor out nicely. And other times it's just not. So something like 16, for instance. Now finding the axis of symmetry, still not bad. Negative b over 2a. So my axis of symmetry is at negative, x equals negative 1. Then here, bless you, to get the other value of my vertex, I can just plug in here. So let's see. I'd have 4 minus 8 minus 5 by plugging negative 1 in for x. So negative 4 minus 5 is negative 9. Get my vertex set. And then again, my intercepts. Let's see, can I factor this? Anybody tried yet? All right, multiplies to 4. So I could use 2 and 2, or I might use 4 and 1. Oh, we got some. Yes?
Wouldn't it be negative 16?
Did I do something goofy again? I'm going to cuss myself out in a minute. Okay, so negative b over 2a. For which one?
Where you have 4.
Oh, okay. No, because on here, I'm just squaring the x. I'm not squaring the whole quantity. If that had been in parentheses, absolutely, that would have been 16. So let's see. Anybody found a factorable way of doing this, or do we have to go to the quadratic, which isn't the worst thing? Anybody? They're like, no, we're just going to use the quadratics. It works every time. Probably not a bad idea. I'm still not willing to give this up yet. Oh, and for good reason. Okay, it is factorable, but again, if you use the quadratic formula on it, it'll still work for you. So it's not like if you choose the wrong thing, you're kind of done. But here, that'll go ahead and I'll be able to factor it out that way. But again, that's the nice thing about the quadratic. If you do struggle a little with factoring, it gives you another plan to be able to get to the answer still. So I'm going to take each of my quantities here when I factored, set them equal to 0, and then solve those to get my solutions. And again, it'll work either way for you, though. And then finally, we kind of get to take what we've learned and put it what we learned when we were playing with some of the graphing things before, which is going to be my suggestion here. Now, what I could do, let me wait before I go to the calculator. When it talks about my maximum output and maximum profit, notice with that negative, this is going to be opening downward. So when it talks about my maximum, it's basically telling me find your vertex. So here are your options, because I always like to give options when they're there. So if I had access to the calculator and like playing with it some, I can go ahead, I can type this expression into my calculator, Now, I don't see that real well, so let's play with the zoom a little bit. So now, let's see what my window's gone to here. Holy cow. All right. I want to make my X max a little bigger so I can see more. There we go. So I see the top of my parabola. I want to find the maximum because, well, that's going to give me all the values I want. It's also my vertex. So if I did my maximum somewhere again to the left of where my vertex is at, and this is just a way that might go a little bit faster than having to go through the whole quadratic here. Somewhere over here to the right, and then I'll get back towards where it's at up here. And what it would tell me is, what's the maximum output? Well, I don't know what they're outputting, but they're going to output 10 of it. And their maximum profit would be my Y value, which is 405. And again, I could do that just like we did back in 13 through 16 by finding the axis of symmetry, my X value of my vertex, and then plugging it in. I get the exact same thing. So either way, because again, if I were here, I'd just have X equals negative B over 2A, negative 80 divided by negative 8. My X value is 10. And then just plug that in. So I'd have negative 400 plus 800 would be 400 plus 5 is 405. So either way works. It just depends on how you want to go about it. And again, the more tools we got in the toolbox, the better. So now, today's work, this would be our next homework check, not this one. Assignment number 1 for homework check 9, which will be like later next week. I'm not sure how later yet, but we'll see. But that's how you can use these. And then like I said, we'll work on the quiz preview tomorrow to get you ready for that going around the corner. So tonight, just make sure the homework check stuff is done and start working with this sum.